Hey kiddos, today we're going to be talking about algebraic and geometric reasoning, okay? So, aka basically we're going to be working on proofs, okay? You're either going to love this part or you're probably going to hate it. Yay! So, let's go forward. All right, so a few algebraic properties of equality, okay? So let A, B, and C be real numbers. All right, so we have the addition property that if A equals B, then A plus C equals B plus C. You have your subtraction property. If A equals B, then A minus C equals B minus C. Multiplication property, if A equals B, then A times C equals B times C. And of course, division property, if A equals B, then A divided by C has to be equal to B divided by C, with knowing that C cannot be equal to 0. All right? And a few more properties here. Substitution property. If A equals B, then A can be substituted for B or B for A in any equation or expression. So they're interchangeable. The distributive property. You have a distributive property with sum, A times B plus A times C. And then there's also the difference for distributive. A times B minus A times C. The reflexive property, A equals A. Symmetric property, if A equals B, then B equals A. So kind of flipping it. The transitive property, that if A equals B and B equals C, then A must equal C. Now just to talk about some angles, okay, so some geometry here. We have something called linear pairs, all right, and linear pairs are adjacent angles, so meaning that they're two angles that are literally side by side. They share a common side, okay. They have their non-common sides are opposite rays, okay, so rays going in two different directions. They create a line, okay. Angles in a linear pair are supplementary angles, and what's important to know about supplementary angles is that those are angles that add up to 180 degrees, all right. So in this picture here, you have angle 1 and angle 2. So here's angle 1, here's angle 2. They are considered a linear pair. They're considered supplementary angles because they are on a line, and a line has a degree measure of 180. All right, another one here, we have our vertical angles. Now, vertical angles are sides form two pairs of opposite rays, okay? Vertical angles are basically angles that are directly opposite of each other, okay? Notice the cool thing about vertical angles is they essentially, where they meet, they create a V shape, vertical, okay, V shape. So those angles here are going to be congruent to each other. So that's what's important about vertical angles. Vertical angles are congruent to each other. So in this picture, angles 3 and angle 6 are vertical angles, so therefore they're congruent. And angle 4 and angle 5 are vertical angles, so therefore these two are also congruent to each other. All right, so let's jump right in onto a proof, and this is what a proof looks like. You're basically going to have a column of statements, and they're going to have a column for reasons, okay? So write the property that justifies each step, and you have the whole list that I already went through. So let's look here what we got. So 5 times 3x minus 2 equals negative 6 times x plus 1 plus 3. That is our statement that we're starting with, and the reason is it's given to us. Okay, obviously they got to give us something to work with, so that's given. All right, so let's see what happens here. We have 15x minus 10 equals negative 6x minus 6 plus 3. Hopefully you guys can see that they use the distribution property. So that is our reason, distribution. All right. Next, 15x minus 10 equals negative 6x minus 3. So you're kind of looking at how did they change. So from this step, how did we get to this step? I noticed that they did something here with the minus 6 plus 3, and they got negative 3. So it looks like our reason here is going to be substitution. All right. Next, we got 15x minus 10 plus 6x equals negative 6x minus 3 plus 6x. So it looks like they're getting rid of this negative 6x by adding the 6x to both sides. So that is going to be addition. All right, well, when we add it, when you actually do that work, 15x plus 6x, you get the 21x minus 10 equals, they cancel it out on that side, bring down the negative 3. So that's our next one. And that reason is also going to be a substitution. Okay. Next here we have, next step is 21x minus 10 plus 10 equals negative 3 plus 10. So it looks like we're trying to get rid of this negative 10 by adding 10 to both sides. So the reason here is addition. We're adding 10 to both sides. All right, so now that we've actually done that, in the next step, we're demonstrating that, and what we're left with is 21x equals negative 3 plus 10 gave us 7, so that would actually also be a substitution step. We actually did the work there. So now we're left with dividing, it seems, both sides by 21, because that's the value with x, and we got to get it by itself. So that's going to be a division. So we end up with x equals 7 divided by 21 reduces to 1/3. So our final reason to have our answer is substitution. All right. Some more justifying, but you guys actually also get to work on writing out the steps as well. The first statement is 3x plus 2 equals 23 minus 4x. And that reason is always going to be the same for every proof you ever do for the very, very, very first one. Typically, 99.9% of the time, it's going to be given. All right. So from here, trying to figure out what we would do next, our next step would probably be to move this negative 4x to both sides. So when I write it, it'll look something like this. 3x plus 2 plus 4x equals 23 minus 4x plus 4x. And that is our addition rule. We're adding 4x to both sides. So let's actually work that out. If we add 4x to both sides, we end up with 7x plus 2 equals to 23. And that reason would be to substitution. All right, so now if we have 7x plus 2 equals 23, got to solve for x. So I got to get rid of this plus 2 by doing the opposite. So I'm pretty sure that we're going to do a minus 2. Okay, so 7x plus 2 minus 2 equals 23 minus 2. So I'm subtracting 2 from both sides. So that's going to lead to a subtraction reason. And when I actually do that work, you left with 7x equals 21. So that would be the reason as substitution, actually doing it. And last step here, looks like we're going to have to divide and divide by 7. So that is going to be a division as the reason. And when we actually work that out, 7x divided by 7 equals 21 divided by 7, you're left with x equal to 3, which is substitution as the reason. All right, now to throw some geometry work into the mix, we're going to use the diagram and the given angle measures to find the other 3 angle measures. All right, so here you have 4 angles, okay, and they tell me first that we're going to assume, or not assume, they're telling us that angle 1 is 117 degrees. Now remember, 2 things here. We're looking at vertical angles, and you also have linear pairs, okay? And linear pairs are supplementary. So remember, our vertical angles are congruent, and our linear pairs are supplementary, which means they add up to 180 degrees. All right, now I will be honest, the very easiest thing to ever identify are vertical angles, okay? And the nice thing is they're the same. They're congruent. So, let's see. I would say that angle 1 has to be congruent to what angle? What is it vertical to? Hopefully you're saying 3. Okay, are there another pair of vertical angles? Hopefully you're saying yes. Angle 4 would be vertical with angle 2, so therefore they're congruent, all right? So, in saying that, if I know that angle 1 is congruent to angle 3, then I know angle 3's got to also be 117 in this case, okay? So to find the other two angles, though, we can create linear pairs here. So let me kind of show you here. If I kind of draw that out. There. These two angles here that are side by side are adjacent, okay, because they share a common side, all right? And notice this is a straight line, so therefore this creates a linear pair, so therefore these two angles are supplementary. They're a linear pair. So all I have to do to figure out what angle 2 is take 180 and subtract it from 117. So 180 minus 117 gives me a grand total of 63 degrees. So if angle 2 is 63 degrees, then because angle 2 and angle 4 are vertical, angle 4 has got to be the same. All right, now let's look at the next option. The next problem, okay, where we're given that angle 2 is 59. Okay, so let me kind of scratch that out. Right, and this is 59 degrees. So if that's 59 degrees, remember, like I said, it's always easiest first to do your vertical angles. We already have stated that angle 2 is vertical or congruent to angle 4. So if angle 2 is 59 degrees, then we know angle 4 has got to be the same thing. Now, to find a linear pair, notice I could use the exact same example I used for the previous one. These two, angle 1 and angle 2, they line up adjacent to each other on a straight line, so therefore they are supplementary, which means they add up to 180. So to find that answer, all I have to do is say 180 minus angle 2, which is 59, gives me a grand total of 121. So angle 1 is 121 degrees. Well, angle 1 and angle 3 are vertical angles, so they have to be the same. So then angle 3 has to also be 121 degrees. Oh, yay. Describe and correct the error in using the diagram to find the value of x. So again, remember, two things we're kind of focusing on here. One, vertical angles are congruent. And number 2, supplementary angles or linear pairs, okay, they add up to 180. So this first problem, A, let's kind of see where they're working with. 3x plus 45. So 3x plus 45 is this angle here, all right, plus 19x plus 3, which is this angle here. Now, what relationship do you think those two angles have? Are they supplementary or are they vertical? Hopefully you're saying they're vertical. And if they're vertical, would we add them and make them equal to 180? No, 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 no. We would not do that. That is where the error lies. What we would do instead is we would make them equal to each other because they're congruent. So this will become our new problem. So all of this is wrong, okay? So they should have actually made these equal to each other. So now we can solve this. I'm going to subtract 13x to both sides. That cancels out. I'm left with 45 equals 19x minus 13x leaves me with 6x plus 3. All right, solving for x. Got to subtract 3 to both sides. 45 minus 3 is 42 equals 6x. That cancels out. last step here is going to be divided by 6. And when we do that, we get an answer of x equals 7. All right. So that was the correct answer of what the value of x would actually be if they had not made this mistake. They should have realized that these two angles are actually, in fact, vertical. All right, let's look at B, where they messed up. So 13x plus 45. Okay, so it's this actual angle again we're looking at. And the 12x minus 40. This one here. Okay, so we're looking at those two angles, and it looks like they're on the straight line together. So if I notice that they're on the straight line together, that's probably hinting me at the fact that they're probably linear pair, which means they're supplementary, which means they add up to 180. Okay, I see that they did the adding part, but where they... Oh no, they said 90. This is not complementary, which is 90 degrees, throwing that vocab at you. It should, in fact, be 180 degrees. So, according to this, the only error they made was instead of 90, it should be 180. So, technically, all this math part is right. The 13x, plus 12x is 25x, and positive 45 minus and 40 is a positive 5. Yeah, so far they actually did this part right. 25x plus 5 is the equals to part that they got wrong. Should equal to 180, not 90. Okay, supplementary. So let's actually fix this now. So now that we know that, box around my variable, I'm going to subtract 5 to both sides. 25x equals 175. And if we take 175 in our last step here, you guys know is going to be to divide both sides by 25. And when you do that, you get x equals 7. Word. As we should have, because that's what we got in the previous problem. Okay? X is 7. All right. Find the value of x and y. Okay, so now it's you using the same skills we used in the previous problems to work this out. So remember, I've always told you it's always easiest to find vertical angles because vertical angles are congruent. You just set them equal to each other. All right? So I know that 8x plus 7 is vertical or congruent to 9x minus 4. And I also note that 5y is going to be congruent to the 7y minus 34. Okay, hopefully you guys are taking note of my different markings here. If they're congruent, I use the same marking. All right, so for the first problem, let's solve for x. 8x plus 7 equals 9x minus 4. Let's subtract 8x to both sides. You get 7 equals 1x minus 4. We're going to add 4 to both sides. 7 plus 4 is 11 equals x. So x equals 11. All right, now to find and solve for y, we have to use the other pair of vertical angles. So we get 5y equals 7y minus 34. So I'm actually going to move the 7y because I want to get y by itself. So I do end up with an ugly negative answer, but that's all gravy. Negative 2y equals that canceled out. Bring down the negative 34. And my last step is to divide by a negative 2. And my answer is going to be positive because negative divided by a negative positive answer, and that is positive 17. All right, so hopefully you guys are kind of getting the gist of vertical angles. Now, I will mention it would not have been a good idea for me to go with the linear pair, the supplementary, because I would have a combination of x's and y's together, and that would not have worked out at all. Okay, so always, anyways, look for vertical pairs because they're always the easiest to deal with. All right, so this example I would like for you guys to do on your own. All right, so if you need any references, you can look back at the previous problem. Remember, you're looking for x and y, okay? Think about your vertical angles and your linear pairs, because that's what's going to help you. Once you solve for x and y, I'm actually adding an extra step here for you guys, okay? I actually want you to plug back in those values. So once you solve for y, for example, because notice I'm asking you to find angle 2, and angle 2 here is 16y. So once you know what y is, all you have to do is substitute it back in and solve to tell me what is the actual degree measure of that angle. And then you would do the exact same thing with angle 3, which is right here, which is the 6 times x plus 2. Make sure you guys remember that this is a distribution, FYI. All right, so example 7. Identify the pairs of congruent angles in the figure. Explain how you know they're congruent. So I somewhat went ahead and started you guys off. So let's look at angle CML. Now, when we're looking at angles, always go in the order of the letters that they give you. Okay, so angle CML. Okay, so angle CML. And I'm asking what other angle would be congruent to CML. Okay, think about your vertical angles essentially here. And CML would be congruent to DMN. Okay, angle DMN. And the reason why would be because vertical angles. All right, next example. Angle LMA, okay, and I'm looking for an angle that's congruent to LMA, and again, think about your vertical angles probably. It's usually the easiest thing to look for. Do we have one that's vertical to angle LMA? And I believe we do, and it would be angle BMN. And the reason why? Vertical angles again. All right, next one, angle CMB. All right, so it's this one here that's labeled with this 90 degree CMB. So does it have anything congruent to it? Hopefully you can see that angle DMA would be vertical to it. So therefore they are congruent by the rule of vertical angles. Next one, angle CMA. Angle CMA. So this whole thing, CMA. What would be congruent to CMA? Well, we're going to look at BMD. Again, the reason why BMD is vertical to CMA is because they are vertical angles. All right, now let's look again at angle CMA, because technically there's another option that would coincidentally also be congruent to it. So instead of thinking of just vertical angles, let's think about our other option, which was linear pairs. And we know linear pairs mean that they're supplementary, so they would add up to 180. So keeping that in mind, angle CMA could potentially also be congruent then to angle CMB. Notice they create they create a linear pair. Okay, they're side by side. They're adjacent to each other. They share a common ray. And if CMB is 90 degrees, and I know that because of this symbol here, then 180 minus 90 would leave me with 90. So therefore, angle CMA would also have to be 90 degrees. So technically, I can make this mark here. Those would be 90 degrees. So that is how we can justify them being congruent, because linear pairs are supplementary, but this more specifically is based on the right angle. Okay, so because they're right angles. All right. Again, we got two more here. Angle CMB. Okay, there's a few different options. What would be congruent to CMB? We hopefully see that it does have a vertical angle, but there's potentially something else, and that is angle BMD. Notice they're linear pairs. They share a common ray. They're on a straight line. And if CMB is 90 degrees, and we know a linear pair adds up to 180, then that would mean we'd have to conclude that angle BMD, would also have to be 90 degrees. So again, similar as before, they're linear pairs because they're supplementary, but you also want to make sure that more specifically it's because of the right angle. And the last one, angle BMD. I'm going to let you guys fill in what would be supplementary to angle BMD. What would be supplementary and coincidentally then lead to be congruent to it. Here is a riddle for you to solve. All right, so last example, going over geometric proofs here, reasoning. So given that angle 1 and angle 4 are congruent, all right, and given that, so I'd like to identify it whenever they tell me that. So I'm going to mark both of them the same way. Angle 1 and 4 are congruent. So because those two angles are congruent, they want us to prove that angle 2 and angle 4 would have to be congruent. So first thing you start off with is angle 1 is congruent to angle 4. What's the reason? This should always be the easiest one given. It's given information to us. So next statement we have here is that angle 1 is congruent to angle 2. Now, why would those be congruent? Because of vertical angles. So I'm going to make that marking. Vertical angles. Notice I used a different color, but I made the exact same marking because they're congruent to each other. All right, so my next statement would then have to be angle 2 is congruent to angle 4. And the reason is transitive property. Next statement we have is angle 3 is congruent to angle 4. Well, how are angle 3 and angle 4 congruent? Hopefully you're making that recognition that it is a vertical angle. So vertical angles, because of vertical angles, they are congruent. So if that is the case, then we can prove that angle 2 is congruent to angle 3 due to the transitive property. All right, we are done. Sorry that was a little lengthy. Adios.